All right, good morning, everyone. Today we're going to be talking about relational database management systems, specifically PostgreSQL. We're going to be doing a deep dive into how Postgres works, where is it actually located within your operating system, and how does it fall into the stack. During part one, we'll be covering what and why are relational database management systems, and then we'll be covering how could we make a shape of a database on our own with the current knowledges that we have as of now. And then we'll go through identifying all the problems that come from trying to create a database from scratch and the power that comes in from PostgreSQL. Once we have identified those problems, we're going to go ahead and take a break. During that break, we have a couple of reading assignments for us to get a little bit more familiar with relational database management systems. We'll come back for part two, where we'll cover what is Postgres and why we chose Postgres. And then we'll start going into PostgreSQL, how to utilize Postgres, and how to execute set files. At this point, does anyone have any questions over the material that we'll be covering today? Perfect. Doesn't seem like there are any questions, so let's go ahead and dive into part one of our lecture. What and why relational database management systems? So, relational database management systems are incredible for data persistency. That's the main reason why they started coming around, is to make sure that data was being stored, filed, everything was being maintained correctly. As we all know, the most important thing whenever we're working within a project is making sure that data is staying consistent across the entire application, making sure that data is staying secured across the entire application, and making sure that data is just not being in any sort of way leaked or misused throughout an application. Um, if you all take a look at the curriculum goes into a couple of other finer details and a couple of other cases that have happened in the last few years or in the last couple of years that have created specific circumstances that boosted the use of database management systems. Now, there is other database management systems other than just relational database. So there's such a thing as MongoDB, where Mongo works a little bit different than relational database management systems. What we're working with here, we are going to be creating a system that works essentially kind of like a table, right? Whenever we create something, meaning an instance of a class, and I'm utilizing those words specifically because once we start writing these schemas, you're gonna notice that there's some familiarity or similarity to OOP, where headers will be represented up top, and those headers will usually be specifying the attributes that we want. So for example, if we're working within an application that works with students, we would have something like, hey, the student name would go here. Maybe we're tracking their age, and maybe we're also tracking the current grade that they have in a specific class. And then maybe we have something at the very end of, is this a good student? Right? And then all of this would fall under the table of students. All right, so now we just wrote this utilizing, or we have this table that would be the ideal return of how we would keep track of students. Can somebody walk me through creating this class of students if we're working within Python OOP?
Yeah, you do the class, and then um, in the init method, you have like the parameters of ID, name, age, grade, and then good student. I'm assuming is what that is.
Right, so we have self, you said ID, name, age, grade, and then good student. All right, so we pass it into the init method with all those separate attributes.
It's gonna be like self, and then are we supposed to do like the privatize in this case? Maybe like the ID for that?
Okay, so we're already identifying like, hey, we might need some getters and headers for things such as ID. Okay.
And equals ID, and self.name equals name, age equals age, uh, self.grade equals grade, and then same for good student.
All right. Awesome. So here we have our Python class that's able to take in a couple of values. Notice that as of now, we've already identified, hey, we might need some getters and headers for some pretty important stuff, such as the ID. The ID being probably something that we have to ensure that is protected at all costs. But what about name? Is it important for students to have their name all in the same format, all in the same capitalization? Maybe we only want first and last names and we're not trying to include any sort of middle name. How do we make sure that all the data that's being entered into the system is being entered in the same exact format? Because again, we want that data consistency, right? So maybe there's something there, right? If I come over, I could always say, hey, may need some left. Go ahead and move this screen over so we could see what I'm actually typing. May need some additional limiters. Same thing with age, right? Well, is this supposed to be an integer type? Can it be entered as a string type? How do we want to interpret it? And how do we enforce it? Things could be set for grade. Are we talking about percentages? Or are we talking about letter grades? If percentages, how many decimal points do we want to hold? And then there's obviously the good student, which seems like it should be a Boolean value, but we would still need some place to ensure that is a Boolean value for validation. All right. So now in Python, we would have to actually write every single one of these methods out. Whenever we create a name or we go into creating this student portal that we're talking about here, all of these different considerations need to have, whether it's within the menu or whether it's within the class itself, they need to have some sort of regulator, ensuring that all of the information that's being stored here is falling in the correct direction or with the correct values. Right. Well, in PostgreSQL, which we'll see here shortly, once we establish the class and we specify what that attribute needs to be as far as a data, it's going to create those left and right lateral limits for us. Rather than making us, the developer, have to worry about it, it's going to say, oh, you want to create an ID? How do you want me to handle this ID? Is it always going to be incrementing? And by just telling it, hey, this is going to be a serial primary key, then PostgreSQL is going to know every time an instance is created, it's going to be an incrementing number, and nothing is going to ever be a repeated ID number. And instead of having to write all of that logic to making sure, like, oh, well, what happens if the last instance gets deleted? How do I make sure that that last instance that was deleted doesn't share the same ID as a new instance that is created? PostgreSQL is going to take care of that. And we're going to be looking a little bit into all of those different functionalities here shortly. Things like name, once we specify that this is going to be a string, it's going to make those left and right lateral limits for us. Same thing with age, and same thing with Boolean values. So that's just a quick overview of what we're about to dive into. First, I want to make this student portal utilizing nothing but the Python OP and the students that and the skills that we've learned up to this point, just so that we can identify the hassle, right? the problem of not having a database and how to manage data and the difficulties that come with managing data without actually having a formal database. And then during part two, we're going to actually create our formal database for our students. We're going to see how easy it's going to be to manage the same amount of data in the same portal in a much faster way. Does anyone have any questions regarding this quick example or this quick overview of what we'll be covering today?
In this case, like self.name, would we want it instead to be self.first name and self.last name?
Well, let's take a look. Let me go ahead and take a look at the CSV here. So our CSV would have things like that. So let's go ahead and change that. We can see that it does have an ID, first name, and last name. So there's no such thing as good stud. We could always get rid of that. Let's move this grade, move this age here. And here we have first. And last. So we're going by the CSV file. This is more of what it would look like. And let me go ahead and change that here as well. Get rid of this good stud portion down here and fix my initializer. All right, there you go. That's more what it would look like if we're going by the CSV file. Is that where your question originated from, Chase? Okay, I see the head mounts. Awesome. All right. Any other questions? All right. If there aren't any other questions, then let's go ahead and start working with this Python file here. Here we have Python in main.py with a completely empty script. Let's go ahead and actually get a little bit of template code here. I'm going to go ahead and import CSV because I know I'm going to be working with a CSV file. And I'm actually just going to bring in that code that we have already written over here. Maybe. Maybe. All right. So here's the code that we have already written in our class. We have our class of students, which has an ID, our first name and last name, age, all the different methods that come in it. This should be ideally privatized, but for our first draft, let's go ahead and just leave our getters and setters out of the way. Now, whenever we work with data, usually data is going to be exchanged within some sort of file, whether that's a JSON file or a CSV file. It could be something like XML as well, but those are rare. Let's just, for this purpose of this class, we're going to concentrate on CSVs. So now I have this main.py function. I want to be able to grab data or read student data from a file name. How could I create some sort of method that would be able to open up a file and create students from said file?
Maybe like a class method, right?
All right. So go ahead and create this class method here. What does this class method do?
Read CSV or something. Yeah.
All right. So let's say read CSV file. Let's make it a little bit more specific. Let's say read student CSV file. All right. This is going to take in self because it's
It's a class method, so CLS, I believe. Yeah.
perfect. Yeah.
And file path.
Okay.
So,
Yeah. It's taking the file path as well.
and maybe we could create like a list for students.
All right.
and with open file as CSV file, I believe.
with open, and
That'll
then
be the path.
Oh, that's the path. Oh, okay, okay. File path, uh, mode, read mode equal read, I believe. It's how, oh, okay, read mode, new line, just like an empty parenthesis, as CSV file. And so we CSV dict reader, if I can remember correctly, is where my notes.
Yeah, you have to create a variable first.
Okay, a reader variable, CSV file inside,
all right.
and for row in reader, uh, if student in file path, was chase.
Sorry, could you say that one more time?
For student in file path, um,
Inside of this, so for students,
in file path, student equal our class equal class students and row, what's it called, deconstruct rows. So we're trying to read the rows, each row, right?
Do
And
you have to do that second for loop?
no, I believe it's if students, we could use like an if statement, right? Am I right? Right. If student in file path
so instead of the for loops, checking if the student is within file path.
is within file path, yeah.
Aren't you just
Uh,
appending the student list that you created with a deconstructed student with the data consisting of row?
oh, okay.
I'm asking a question. That's what I thought it was.
Uh,
I don't think you need the if statement because it's going through each row already. And I think all you just need is like student equals class star star row, and then append that student to that student instance to the student's list.
Yeah, you shouldn't have to name the student variable. You would just say your students list dot append student class deconstruct row.
okay. I was thinking append comes after student class, right? I was thinking you append student after student class, but maybe I'm wrong.
I see. So you're saying something along these lines.
Oh, yes. I
Yeah, I think that's correct.
You don't have to declare the student equals CLS row.
Oh, okay.
You can just do students dot append and then your student class deconstruct the row.
Well, what's
I
the
was
name of
thinking
that instance going to be then?
student equal the class student row, student and row, append row to student class, right? That's what you're saying, Tim, right?
I'm saying you don't have to name it a variable students. All you have to do
Okay.
is the students is the list, so students dot append, and then what you're appending is an instance of that student class. So you use the actual class name, and then you deconstruct the row within that for the data, and then all the data for that it'll be turned into an instance of that class within the student list.
So you're saying student class dot append. That's what you're saying.
No, I'm saying students list dot append, the list that
Oh,
you
student
created up
list.
here.
Okay.
And then what'd you call your class? It's class students, right?
Yeah.
So I'm saying row 18 is unnecessary completely.
Okay.
And I don't know where that CLS is coming from.
Yeah, so because this is a class method, CLS is represent
Oh, okay.
class
I see.
itself.
Yeah, I got that. Thank you.
Of course. All
So
right.
you can kill row 18 and you just do students that append CLS. Row 19 is what you need.
Okay.
Yeah, so
Thanks.
what you had works as well, Morty. Great job getting here. They're just trying to walk you through a more efficient way of writing that code, right? So
Okay.
after
Perfect.
every row, there would be an instance of the class already within that list.
Okay.
I have a question about that.
Yeah.
So with taking away the previous line 18, how would you like reference that class instance if there's no variable to call it by?
How would I reference the class instance if there's no variable to call it by?
Yeah, like that class instance was student equals class row. Um, so wait, I think I'm overthinking it. Okay, never mind. I understand what Tim is saying now. I understand it.
Okay, awesome. All right. Okay, so moving forward now, we were able to read from the CSV file, and it creates a list of specific instances, right? A list of all instances of a student. At least that's what it's going to try to do. Now, once it is done, we want this function to return a specific value. All right, so what is it that we're returning here?
The class instance.
The list of students.
Yeah, we return our list of class instances, which is our students. Great. Awesome. So let's go ahead and break this down a little bit. So the CLS here is representing the student's class, which apparently it's not going to let me do that. But we know that we're going to need a string here. And we know that at the end of this, this is going to return a list type of students. Why isn't it able? Oh, it is because it is within the class itself. Okay. Little bit trickier syntax to try to specify what's going on here. But we know that this is going to return list of class instances of students. All right, it's looking great. So now we have a read student CSV file function. Let's go ahead and put this into practice a little bit before we move any more forward. I'm going to go ahead and make a function for our menu here. Or let's just say student portal. This function of student portal, that it's going to have a menu. Say, what would you like to do? So option one, see all students. Option two, load students from a file. And let's leave it at that. So now this is our student portal that's going to be continuously running. How would I go about managing this input or this menu to being able to hold students or seeing all students all together? All right, let's tackle it down one at a time. Where would
I don't,
oh,
I'm sorry. I don't quite understand the question.
yeah, awesome. I just basically want to build this functionality for these two options that are down here. How would I go about utilizing the code that I've created up to this point in order to build out this functionality?
Oh, okay. So you need to, if your student list is privatized, which is not, you don't have the student list anywhere other than the student class method, right?
I believe that's correct, right? We don't have anything for a list of students.
So with If you want to see all students, you're going to have to create another way to see all the students because you're not going to run that class instantiator every single time.
Okay, awesome. So maybe we have something like, hey, where are all of our students, right? So
And
let's,
then you can get a getter method if you privatize it, and if not, just build a method to return it.
all right. So now we have our current students here, which is where we'll store students as they're being read from the CSV file and so on. What else?
You need a method to return it.
Okay, so let's do that. Let's go ahead and say, all right, we have our menu. Let's ask for user input. Let's call it selection or something along those lines. Ask for the input and pass in the menu function here. Here we can start with our if statements. So if selection is equal to 1, we'll simply just iterate through all of those students. So we'll go ahead and do a list, say print x for x in current students. All right, so there's our first for loop to be able to see all of our students that have been created.
You're going
And
to need a repr as well.
that's what I was just about to say. Yeah, we might want to add a repr method here and return. Let's say self.first name, self.last name is self.age with a grade of self.grade. All right, so there's our representation method. We have a way to actually be able to list out all of the students. Fantastic. Now let's do elif selection is equal to 2. And obviously we need 3 width.
If it's equal to 2, you're going to have to uh, go through the list of students and find the student based on probably ID, but
Okay.
maybe whatever variable you want to use.
All right, so for number 2, we're doing load students from a file. So
Yep.
in order to load students from a file, we have this method that we created for reading students. So how do we apply that? And let's hear it from, I'm going to go ahead and start calling on people. I really appreciate it, but I want to make sure that everybody gets some participation here. So let's hear it from Kenny.
What was the question one more time?
All right, so the question is in option number 2, we have to load students from a file. Currently, what we have is a class of students. We have a file named students.csv, and we have a class method that can read from a relative path.
I would. Oh, sorry, I'm on two devices.
I would say, can you scroll down a little bit?
Further?
At line 38, I would call the function that would initiate the, I forget what we called it, read student CSV.
All right, so let's do students dot read student CSV file.
Say from there, wouldn't we have to prompt the user first the file path, or would we just automatically add the file path?
Yeah, let's go ahead and ask the user for that. Let's say file name. Let's say input. What is the name of this file?
From there, just parentheses, file name.
All right, awesome. So there we go. We have our file name. We pass it into our function. Our function will look within this directory for a name matching that set file. If it finds one, it's going to try to read it as a CSV file. It will then create the reader with dict reader, iterate through each one of them, create a list, and receive said list. All right, what's next?
From there, I would assume to print out I'll say, since it's a list of instances, kind of copying line 35, print X for X in studs from CSV.
Okay. All right. So we just want kind of let's do that. Okay, so that will list them all, but they're still not being saved. Remember, this is where all of our current students are being stored. So where would this go?
I would say after print, comma, current student, append X.
So current students. So you're saying here, after this print, do current students dot append X.
Mm. So in the same operation, it prints out and also adds each instance to a list.
Actually, not sure if you could do multiple functions. Looks like you can. Nice. Okay, awesome. So now we're able to print and then afterwards add it to our list. Do we want some sort of success message at the end of it? What else do we want to do?
I was gonna say, can you scroll up a little bit? So what is the purpose of the current students? Because can't we just make a class attribute and have the read students functions at the end just give all its properties to that attribute?
We could create a class for a school, and that's where the students would live, but it wouldn't live within the student's class, if that's what you're asking. So the purpose of this current students is essentially we're not creating a whole student, excuse me, we're not creating a whole school class that would hold students. So instead, we're concentrating on this function of student portal and just setting it as a global variable of current students so
Oh,
that we can continuously interact with it while the program lives.
now I'm realizing I thought that was part of the class this whole time.
Got it. All right. Awesome. Thank you, Kenny. So now that we have this, let's go ahead and just print a students have been added. And let's return our function here. Let's add an add statement hit there or an else statement that will print incorrect input. Return our function. And then let's have a final statement here for 3 that will just print goodbye for now. Sorry about that, everyone.
I guess one thing I'm thinking is if you didn't load the students beforehand, and you tried to say see all students, I mean, you need some kind of error message saying first load students or something like that.
Okay, so you're saying let's put a little bit of error handling there as well. I agree. So if we come up here, let's do a little bit of if current students, and let's do something like len is greater than 0. Then we'll trigger the following. Else, we'll go ahead and print, you must load students from a CSV file first.
Yeah.
All right, great. Let's go ahead and run this real quick. Let's run Python main.py. Oh, didn't call the function. That will do the trick. All right, so let's go ahead and put option 1. Tells me, hey, you must load students from a CSV file first. Great. Let's load students then. So what's the file name that I'm trying to look for? It's called students.csv. And there it gives me a little bit of a record there. So now it tells me, hey, John Doe is 18 with a grade of A. And if we take a look at our CSV file, that worked. Then we have Jane Smith is 19, Bob Johnson, 20. Great. All of our information was added or hypothetically added. Let's go ahead and confirm that by pressing the number 1. Now we don't get our message saying that our list is empty. I can put some gibberish on there and it'll tell me, hey, there's incorrect input, but my values will still exist. And then I can quit my program and it tells me goodbye. All right, awesome. So as of now, pretty good logic. I like it. There's definitely a couple of things that we have to take into consideration, right? So 1, great job handling and creating all of this information. But what happens if I pass a file path that isn't valid? How would my program react to that?
Wouldn't it just like basically break the program?
Awesome. Yeah, that would essentially just break the program, which means what would happen to all the data that's currently within current students?
It wouldn't load.
You'd lose it.
Yeah, I would lose it, right? Because once the program is broken and the script is completed running or is done running, then all of the current data or the memory that is being used to hold my data would disappear. It would go away. All right, so let's continue moving forward here. I'm going to go ahead and take over the wheel because we are starting to look at a little bit of a time issue. So let me go ahead and dive in here. So the one issue that we came up here is, all right, well, what if this doesn't work, right? It would throw an error and we have no way of handling this error here. So instead of just leaving this out open, I'm going to go ahead and put it in a nested try block. And say, hey, I want you to try to read this file. If it doesn't work, I want you to grab the exception. And I just want to print, hey, there's no file matching the input provided. And then I want to return students as well. Regardless, I'm still returning an array. That way everything else in my program doesn't actually break. We're not going to go over the process of creating a student because as we talked about, there's so many other things that we have to make sure that get enforced there. But there's one, right? Making sure that that's happening as far as handling it for improper input for the student CSV file. And now 2, well, I wanted there to be some sort of data retention. So once I want there to be some sort of data retention, how would I go about creating this data retention? I want to write, or I want to potentially create new files where I can hold and write said information. So maybe I need to create a new class method. And this one will be to write student CSV file. It will take in a file name and CLS, of course. Let's go ahead and also pass in all of the current students as well. All right. Now, what we want this to do is I want it to be able to write a row per a student. So I'm just going to say, hey, I want this to be a writer. This is going to utilize CSV writer. It's going to take in the file name. That file name is going to get passed down. Going to say, hey, in writer, I want you to write row for all of the components within my class itself. There's a couple of different ways of doing this. I wonder if I could use destructuring to do this. But for simplicity's sake, to avoid any sort of experimental information, I'm just going to go ahead and pass in all of my headers for the very first row, which is going to be ID, first name, last name. We have age and grade. All right, all that gets passed in. There's my very first row, which is just my header row. From there, I'm going to iterate through each one of the students. And I'm going to write a row. I'm going to say writer.write row. And in this row, I'm just simply going to pass stud ID, stud.first name, stud.last name, stud.age, and stud.grade. All right, same thing. Probably want to put this within a try and except block just in case there is an issue. So I'm going to try. Then I'm just going to simply return a Boolean. Then I'm going to add my except block. I'm going to print the error so that I know what happened. I'm going to print data was not saved. I'm going to return false. This is going to be a function that returns either true or false. True if it successfully saves information, false if it does not. So with that said, let's create a new file here. This file is going to be for today. So let's call it February. So Feb, it's the 27th, 2025.csv. Say it's a program that runs daily, and that's how we save our information. Well, when I quit, I should have a data or save data information here. Or maybe at the beginning of every time this function gets called, I save the data. Kind of depends on how we want to do it. But let's go ahead and do it after our goodbye here. Let's say save data. That's going to equal to students dot save, or what did I call it? What did I call this method? There it is. Write student CSV file. It's asking for a file name. Guess we could ask for that. Let me check something out here. Thought I knew that one off the top of my head. Let's go ahead and ask for it. All right, so now we're grabbing our current date. We're providing a bit of an example there. Let me make sure that I add a new line. And then we can go ahead and finish off this mess here. Now we can say if safe data was successful, we'll go ahead and print goodbye and break our function. We don't even need to break. Otherwise, we'll say print data not saved and return the student portal. All right, let's run this logic here. So let's take a look at our February 27th here. I can go ahead and try to see all students. It's going to tell me, hey, there's none. You have to load one first. Okay, I go to students.csv file. Great, now I get everything loaded. I'll go watch all students, fantastic. I want to exit. Well, what's today's date? Today's date is February 25th, 2025. All right, and I did get an error because it is not the 25th, it is the 27th. But let's see what the error tells us here. Student.Bible CSV missing one positional argument students. Oh, that will do it as well. So they didn't even get into my function. I just completely forgot to pass in current students as well. All right, let's load some data. We can make sure all data is on board. Try to quit. It is the 27th, 2025. We pass it in. It tells me data was not saved. Must have a write method. Argument 1 must have a write method. That is happening. Where at? Happening here. Oh, that will do it. Totally forgot this fancy dandy with open. All right. Let's try this one more time. Mistakes are imminent. Here we go. Students.csv. Great, great. Let's try to quit this time. 27, 2025. There you go. Now it tells me, okay, well, this was successful. Goodbye. And now if we take a look at February 27, 2025, our data has finally been saved. Now, why is that writing method important? Why is it important for us to have it when we quit?
Is it so that every time you run the file, like this the main file, like it doesn't have to run the import every time?
Yeah, that's a great question. So maybe what we need to do is later on, once we make this a little bit more sophisticated, the way our current student portal would work is the first thing it would do is it would load all students from either the current date's CSV file or the previous date's CSV file to ensure it holds the newest record of data. Right, so that would be something that we would have to load as or create a new method for. And essentially, as our program continues existing, or every time this script gets executed, the first thing our script would do would look for a file either named with today's date or the date prior, and then load all the students that are already pre-existing. Did that answer your question, Chase? Or not a question, but did that follow along the lines of what you were saying, Chase?
Yeah, that like cleared it up.
All right, awesome. Another thing to take into consideration is we decided to utilize a list. Likely not the best data structure to use when we're trying to grab something with direct access or ensuring that specific keys are unique for specific values, such as an ID. So maybe we should have changed this to be work within a dictionary. But that's going to be food for thought that we can use to improve this program later on as we move forward. Now, this was a very simple interface, and creating this interface from Python from scratch took a considerable amount of time. During part two of our lecture, we're going to dive into essentially not building the menu, but we're going to see how much easier it is to manage all this information within a CSV file inside of an actual Postgres database. This is going to conclude part one of our lecture. I hope everybody saw and got to work through the troubles and the hoops that we had to create in order to just get this portal functioning for just those two options. And imagine how much more work would have needed to be done if we wanted to add the option for creating or adding a new student into this file. All right. At this point, does anyone have any questions over what we did during part one? Okay, fantastic. Let me go ahead and pause the recording here. All right, welcome back, everyone. I hope everyone enjoyed those reading assignments. And now let's go ahead and dive into the world of PostgreSQL. So during part one of our lecture, we went over how we would do the or conduct this kind of functionality with students, utilizing this class of students and how it would work with Python. Then it took us down a huge rabbit hole just to be able to select all of the current student instances or even save them. Now let's take a look about PostgreSQL. How do we generate this table? How do we enter Postgres all together? And how we can execute some of this information. So I'm going to go ahead and open up another terminal, and I'm going to open it here in VS Code just so that it's more readable to everyone. I'm going to zoom in a bit. And I'm going to close down this portion there. All right, so why PostgreSQL? PostgreSQL has been around for a while now, and it's able to pretty much merge into any stack that you can see in the industry nowadays, as long as they're using relational databases. Your PostgreSQL has become very dynamic, very popular. There's a lot of cloud-based decisions or a lot of cloud support within AWS as well for PostgreSQL. And it's just a very popular database overall. So that's the reason why we chose it. That's why we're diving deep into Postgres altogether. Now, in order to work with PostgreSQL, if you look at our curriculum, it immediately starts giving you schemas and different commands that you can run. But before we dive into any of that, I want to make sure that we do a quick introduction to how we can enter, exit, or just what is Postgres? How do I enter PostgreSQL? So one thing that I want to clarify before we even start diving into PostgreSQL is I want to clarify that within our machine has independent ports. And yesterday, when we created when we created our front end was running on a port, which for lack of better words, let's just say it was 5244. It changes every time because that's just the way that live server works. And later on, when we start working with our Flask application, which will be our backend will be also running on a port. And more than likely, this one will be 5432, somewhere along those lines. Or we could even do port, for simplicity's sake, port 8000. All right. So that's all being occupied inside of my machine. By machine, what I'm referencing to is my laptop, or if you're working within a desktop as well. Whatever your operating system is, that's what's being represented by this machine. Well, now, what about Postgres? Postgres is a background service. We don't actually interact with it or actively bring it to live within a port unless it's your very first time utilizing it. And it's consistently running in the background, right? All of these three parts are independent from one another. And they're all actively running within our machine at once. Later on, when we go to deploy, what we're going to do is we're going to have a virtual machine, which for all of you working not on a Mac, you're already working within a virtual machine environment. So you're going to have the upper hand once we start working within deployment, because everything in there will look somewhat familiar to what you've seen in your WSL instances. So there you go. All right, so here's our virtual machine. Yesterday we worked on our front end. Today we're going to be diving into PostgreSQL. Well, the first thing I want to do is make sure that it's actually installed. So I'm going to run brew services inside of my terminal. And we can see that I have two different databases here. I have Redis, which is currently not running, which is great. And then I also have this PostgreSQL database. It's version 14, and this is the current location of where it's located. Everybody should have something similar to this, and everything should say started. If it does not, please make sure that you speak to a TA this afternoon so that you can ensure that your database is set up and ready to go. With that said, how do I enter Postgres? Because as of right now, if I wanted to run a port on live server, I could click on go live. If I wanted to run a Python script, there's a terminal command that I can utilize to be able to execute commands. But PostgreSQL is not necessarily something that just executes commands. It actually has its own environment inside of it. We want to make sure that we enter this set environment before we can start running SQL queries or SQL commands. But the question is, how do we enter? All right, it's great to know that that exists, but I need to know how to actually, well, get inside of Postgres. When you install Postgres, you also install a tool called PSQL. PSQL is a tool that you can utilize to be able to interact with PostgreSQL. And once you type PSQL, all of us should have a database named Postgres. When you pass this, you'll notice that everything as far as your terminal goes changes. I am no longer Francisco Avila. That is no longer the user that's being activated. And Francisco Avila is no longer at MacBook Pro. Now I'm within PSQL version 14.13 installed by Homebrew. And the user that I'm currently acting as is Postgres. So now I'm within the system of PostgreSQL, and I'm able to execute Postgres commands. How do I get out? Well, \Q will allow me to quit out of the system and go back into my terminal. All right, does anyone have any questions over the dynamic of Postgres, how it lives within our machine, or how we're able to enter and exit from Postgres up to this point? All right, doesn't seem like we have any questions, so let's go ahead and get back in. Going to enter Postgres. And inside of Postgres, there's a couple of very basic commands that we should be familiar with. First one is going to be \L. So \L is going to inform us of a list of databases. And this is, let me go ahead and make this full screen just so that we have it here. This is pretty useful. It gives me the name, the owner, the type of encoding that's happening within this list, collate, we have the C type, and then the access privileges. Who has access to all of these informations? You can see that all of them, the owner is myself. I've created all of these databases, and they're all available for me. All right, awesome. For all of you, when you run this command for the first time, at most, you'll have Postgres and maybe a couple of templates, if that. But please don't freak out if you don't have all of these databases. I created the majority of them myself. All right, so that's \L. Great. Now let's see what happens if I'm going to go ahead and go into this school, and I'm going to connect to a separate database utilizing \C, which stands for connect. And I want to enter the database of school. Well, now when I execute that command, it tells me you're now connected to database school as the user, Francisco Avila. Great. You'll notice that instead of Postgres, which was the database I was in before, I am now within school. If I run the command \L, should I expect a different output, or would I see the different one? Oh, excuse me, or would I see the same one?
I would expect a different one.
Different.
Okay, awesome. Let's go ahead and run it. Well, we have the same exact output. Right? The reason why we have the same exact output is because this is the list of all databases. It is not the list of the tables within the database, but the list of all the databases that exist within PostgreSQL. Now, \D, that is going to give me all of the tables. So you'll see that when I execute \D, it tells me inside of the school, I have two separate tables. Or actually, I have only one table. I have the table of student, and then I have a sequence type inside of it that I can run SQL queries against. But only one table exists. If I go and connect to something like, let's see. Let's go back to econ DB, and I run \D, you'll see that here in ecomDB, I have multiple tables and sequences all categorized here. To include user authentication. And if you ever come all the way down, or at some point you don't want to scroll through everything and you just want you to get your control over the keyboard back again, all you have to press is Q, and Q will quit the current action that's happening and reconnect you back. All right, so \L lists all of the databases. \C connects you between databases. And then \D as in Delta will list all of the current tables within a database. Does anyone have any questions regarding those three commands? All right, it doesn't seem like we have any questions. I'm sure that gets also added to our notes today before it gets pushed into demos and notes, just in case anyone needs a little refresher on this later on. All right. Well, now let's go ahead and actually create a database of school. I already have one. So if I try to run the command create database school, it's actually going to give me an error. And when it comes to SQL queries, because this is a query, you always want to end it with a semicolon, just a syntactical thing. Well, it tells me, hey, error, the database of school already exists. Well, how do I fix that? I'm going to drop the database, as long as I figure out how to type again, of school. It's going to say, hey, a database was dropped. And then I'm going to create database school. Database has now been created, and I can connect to it. \C, school. Now you'll notice that any command that starts with a backslash doesn't have to end with a semicolon. You can run it just like that, unless you're only adding the backslash to void permissions, which we'll cover later on. Queries will end with a semicolon. Commands will not end with a semicolon. They start with a backslash. All right, so now I'm back within my school. And if I run \d, you'll remember before I had a table and a sequence. Now I don't have anything because I dropped the table, meaning all the data within it was dropped, deleted, it's gone forever. And now when I did the \d, it's telling me, hey, there's no relations here. There's no tables that are connected to this database. All right, so at this point, if you are following along, ideally, you would have an empty database named school. Great. Now we can actually start diving into the fun stuff, the good stuff. How do we actually work with our data? Let me go ahead and actually, we don't even need that. We're going to create this schema here. And this schema, what we're going to do is we're essentially going to take this init method and we're going to create our student here within the schema. Now, in order to do that, this is a new syntax that we've never seen before, so I'm going to walk us through it. Instead of just identifying class students, I would say, hey, I want to create table students. Right? It's pretty much a one-to-one exchange there of syntax. I'm going to open up some parentheses. Now, this is a SQL query. So at the end of it, I want to make sure that it ends with a semicolon. So I'm just going to add that in there. That way I make sure that I don't forget it, because chances are that if I don't add it now, later on, I will forget it. All right. So there's my table. I'm creating it, but currently it doesn't have anything inside of it. Well, I'm going to start creating these attributes. I have my ID, which for now, let's just make it a primary key. And then later on, we'll go over the serial primary key. I have a first name. Now, this first name, like we talked earlier, it may require some sort of getters and setters. Maybe there's some way that I want to make sure that values are being stored correctly. I want it to be interpreted as a string. Because I want it to be interpreted as a string, I'm going to utilize this variable character type. Now, there's a couple of different types that you can utilize within PostgreSQL to be able to create strings. Same thing with integers and floats. For now, we're not doing a deep dive into Postgres. This is just a peek. We will spend the full 3 days diving into Postgres and speaking about it later on. But for now, the only one we're going to cover is varchar. Varchar, the way it works is why I'm passing a limiting factor saying, hey, there will be no more than 50 characters that will be stored under this specific attribute inside of the database. Now, does that mean that my memory space should use all 50 characters? No, it doesn't. I want my memory to be efficient. So if I utilize something like character and just passing character, then regardless whether I use all 50 spaces, it will always occupy an entry for 50 characters, which is not good for a long time memory efficiency. Now, variable character, let's say I enter only 5 letters into this attribute. Then the memory space for the remaining 45 letters that would be stored inside of the database would go away and say, this is all you need. You only need to save memory for 5 characters. And that's the main difference between varchar and char. All right, notice that I'm separating all these attributes by a comma. They're all falling within a function, essentially. So I'm separating them by a comma. I have my last name, which will also be a varchar 50. I have an age, which we want to be interpreted as an integer. So if I want that to be interpreted as an integer, I can simply just pass in int. And then I have my grade. which my grade will take in a character of only 1. Now notice before I was utilizing varchar 50. Well, in this case, I know that there will always be an entry of at least 1 character, so I can utilize char to make sure that I save 1 character. All right. One final super key thing that we need to make sure that we point out on line 6, because this is our last attribute and there will not be any other following arguments, you will not add a comma. Here you'll leave it. Comma comes before the second to last at the second to last argument, but the last argument will not receive a comma. All right, does anyone have any questions over this one-to-one exchange? And what I mean for one-to-one exchange is if you take a look at our init method here, it looks almost identical to our create table right here on the left-hand side.
I got a quick question. So I'm assuming we're going to be putting the data from the student CSV file into this table. So does that mean we still need to do the read student CSV file in Python class?
That's a great question. So if you were running a Python program that doesn't handle for some sort of object relational mapping, then yes, you would have to manually type a function that does that for you. Luckily, later on, we'll be utilizing Django, which will not require you to write this yourself. It comes with a built-in tool that basically runs that functionality in the background of churning code or objects into entries inside of SQL. But that's going to be something that we dive into later on. Does that answer your question, Chase?
Yeah, it does. Thank you.
Of course. Any other questions? All right, I'm not seeing any questions, so I'm going to go ahead and clear these drawings here. And I'm going to go ahead and execute this schema. Well, now how do I execute this schema inside of PostgreSQL? Because Postgres doesn't necessarily know where this file is located. Well, right now I just call this schema SQL. It should be unique enough where it doesn't exist anywhere else in my machine. But just in case, I might rename this file actually. Let me go ahead and rename it here. And I'm just going to name it Zulu schema, just to make sure it's a unique name to help out Postgres be able to find it. All right, well, how do I execute this schema? All right, there's got to be a command that I can access within PostgreSQL so that it finds the schema in my machine and executes it as a common query. Well, \I is going to allow me to do that. After \I, I'm just simply going to specify the name of the file or the schema that I want to execute. And in this case, it's going to be Zulu schema.sql. Again, this is not a query. This is a command. It's starting with a \, so it does not need to end with a semicolon. All right, so now it's giving me an error. It's saying, hey, can't find this, doesn't exist. All right. If I start running into issues like this, sometimes what you can do is say, oh, well, let me see. I want to copy the path, right? Here's my absolute path. And then I run \I, put the whole absolute path to it, and then it's able to actually run. And it looks like I have an error here. Let me go ahead and run this here. There you go. All right. So it wasn't able to find my file at first. Once I pasted the absolute path, it was able to find my file to it. But then it told me, hey, you have an error. And my error was that I wasn't specifying the type for ID. I myself assumed that if I put in primary key, the program would assume that I wanted it to be an integer. Not how it works. I have to specify that I still want it to be an integer. And it gives me this create table. Well, all that's telling me is a table was successfully created. Here you can see on the terminal that when I ran \d before, it told me we can't find any relations. Well, now when I run \d, it's going to find one relation. That's going to be of public students, table, and where the owner is myself. All right, and just like that, we were able to essentially create this table or this class within my database. Does anyone have any questions over that so far?
I guess what is it that the \I is really doing?
So the \I is essentially a command for executing a script. I'm not sure what the I actually stands for, but that's what it does. It's saying, hey, I want you to execute the following here. I think a \I stands for insert now that I'm thinking about it. It's insert this SQL in here. Does that answer your question, Jack? All right, awesome. Any other questions? Okay, great. Doesn't seem like we have any other questions. So let me go ahead and drop this table one more time. And now the table has been dropped. So I dropped the student table. And if I run \d, the student table doesn't exist. Now, something that I want to clarify, there is nothing special about this schema. This schema can also be executed within your terminal, or you don't necessarily have to write any of your SQL within a schema. You could do it all within the terminal. I can copy this exact command, paste it here inside of the terminal, and when I press enter, you'll see that everything was executed. I get a create table, and if I run \d, I get back my students table yet again. Now, that brings up the question, well, if I don't need to do it, why am I interacting with the schema altogether? Why am I messing with file paths and even keeping the hassle of having to create a schema and doing things? Well, you want to have a record of all the SQL queries that you run. Not only do you want to have a record, but the majority of the time, you're not going to be actually working with real client data, or at least ideally, you wouldn't be working with real client data. Usually what happens is a fake data will get generated. That fake data will get passed out to whoever needs to actually go into the database and generate reports. And then with that fake data, you would write a schema, right? Because this schema would eventually get pushed to a cloud, where that cloud would actually run it against client data, and it's a whole bigger picture information. But you want to create schemas or get into the habit of creating schemas because you want a living record, and it's also what will actually be shareable code in between developers when you're working inside of the database. All right. Does anyone have any questions about anything that we've covered up to this point? Okay, great. If no one has any questions, I'm going to go ahead and get a little fancy here. I am going to continue to execute this script. So I'm going to add this drop table if exist students. So if the table exists, I want you to drop it. And I'm going to do this every time the schema is generated, just to make sure that I don't run into the error of, hey, this table already exists. I'm going to go back to that \I command, execute it. You can see we got that drop table. That drop table is happening because it existed. And then I was able to generate it yet again. All right. Time to get some dual terminal action here. Now I have my table. How do I actually copy from a CSV file or get the data from a CSV file to enter? There was a question earlier, do I have to write a whole function in Python to be able to do this? You don't. The database actually comes in where you can specify, hey, I want you to copy students. This is the name of the table from, and then you specify the path to your file. I already have this path. I'm just going to go ahead and add the absolute path there. All right. If if at any point you start running out of space while you're working within SQL queries or in any files, just Alt Z will wrap text. That way you're not constantly making new lines. So there's my absolute path to my SQL file. But instead of my SQL file, because that's not what I wanted to grab, I wanted to grab from my students.csv. Let's say students.csv. Check. Okay, students.csv does exist. It does have the values that I need. Great. Notice that I also use single quotes instead of double quotes. Do not use double quotes or capitalization when you're naming databases. So capitalization, don't use it when you're naming databases or tables. And if you're writing a query, always utilize single quotes, not double. Reasoning behind that, Postgres does not play nice with capital letters when it comes to select queries. So just avoid them when it comes to naming your tables and your databases. All right. Now we're going to specify a delimiter, meaning, hey, how are these values being distributed? And let me make sure I'm spelling that correctly. Delimiter. Okay, I am. And then I want to specify that there are CSV headers being included inside. All right, so I'm going to copy students, the table. I'm going to create instances from the file, which is my CSV file, with the delimiter, meaning each value will be separated by a comma. And yes, there are CSV headers. That way it doesn't throw an error for the first row. All right, let's take a look at what happens when I execute my command now. Again, this is a SQL query, so it ends with a semicolon. Let me run this here. Okay, so now I was able to drop a table, I was able to create a table, and I was able to copy 5 instances. All right, well, if I take a look at my file, my CSV file here, I do have 5 students. So that's good to hear that I was able to copy 5 instances. That's great enough. But now how am I able to see the values of all of these students? Well, that's where it takes us into queries. And today we're just going to cover a very basic query, which is going to be select, right? Where we want to select all. And instead of actually writing every single attribute, I could just put a star for all and specify from students. All of these words that are in blue, they are key and predefined words that are working within SQL. You do not have to exchange capitalization and lowercase. This is just common standard when it comes to writing SQL. If you ever get an interview for a data entry or data analytics, and you're writing a SQL document, or someone wants you to write queries in SQL and you don't have the capitalization, they might dock you a couple of points subconsciously, even if your query works, just because of the fact of that you're not following the common syntax practice. It's kind of like snake casing in Python, right? You could also camel case and it works perfectly fine. It's just not the right thing to do, if that makes sense. All right. So now let's go ahead and execute this file one more time. So we get that drop table command because my table did exist. All that data that was in there got dropped as well. We get this create table command because I was able to create a table of students. I get this copy command, which is saying, hey, I copied 5 different new students. And then I have my IDs, or excuse me, my select query returns the table. So now it selected all of the attributes and of all of the instances that are within the student's table. It shows me that there's 5 different IDs and all of their corresponding values. All right, I'm going to go ahead and pause here because we have covered 2 separate commands. At this point, does anyone have any questions over what we've covered thus far?
I don't have any questions about the content, but what would be some reasons why you cannot create a database? Like I'm in Postgres connected to Postgres, and I tried to create database school, and I got no error message, but it did nothing.
Permissions. I would make sure that whatever user you're currently logged in as has the same exact permissions as Postgres. And if you don't log in as Postgres, and then give yourself the necessary permissions.
All right, thank you.
Of course. Any other questions? Okay, great. Doesn't seem like there are any other questions, so let's go ahead and dive a little bit further into our Postgres content. So now we're able to select information, we're able to grab things. Well, what if we wanted to grab specific information about students depending on specific variables, right? I want to run my select queries to be a little bit more selective. Well, I can say, hey, I want to select first name and last name from students. And I can see that I'm going to run out of space. Because this is SQL, I can also indent my queries. I can say from students and end it with my semicolon there. We get our first table there. And then we finally get first and last name. So that's all working as expected. So as you can see, we can select different attributes. We don't always have to use the star sign. There's also such a thing as select count of all. From students. Oh, that's not what I meant to do. That's okay. We can execute that and it just gives you the count right away. So in case you ever need to know how many students are meeting a specific criteria, well, you can also do that. You can group them. You can say, hey, I want to have a grade and the count of all the students. And then you can specify what kind of grades they have by grouping them. So you can say group by grade. So I'm grouping the students, all of them by their individual grades, and then I'm getting a count of how many of them meet that grade. All right, so here you go. I get the grade count. So grade B, C, and A. I have 2 students that have a B, 2 students that have an A, and 1 student that has a C. There's a couple of other queries here. They're all in our curriculum. They're fantastic, but there is some other content that I want to make sure I cover before spending more time in queries, since queries are a little bit more straightforward. So let me go ahead and backtrack here. Now that we have these queries and we're a little bit more familiarized, I want to cover the difference between copying from a CSV file, inserting data, and the difference between a serial ID and just this regular ID that we currently have right now. All right, let me make sure that works. Okay, great. So as of now, when I run this table, there we go. As of now, when the script is executed, it's able to drop the table, create the table. It copies 5 instances. We can see the relationships of how many data tables are inside of this database, which currently there's only 1. And then we can see all of the values that are stored in there. All right, we have our first name, last name, age, and grade. Everything's working great. Well, now let's go ahead and insert a new value here. I want to insert into students, and I'm essentially creating a brand new instance where we have ID, first name, last name. We have the grade. Oh, excuse me. We have age, and then we have grade. And then we can specify the values, saying, hey, these are the following values that I want to insert. Well, in this case, I'm just going to insert one value. The one value that I want to insert will likely be, let's go ahead and try, let's do 6 to make it successful for now. 6, let's do Francisco. Avila, age. And then for grade, I think what was our earlier table count? There was one that was missing. The C. There you go. Let's put C. And then we'll cut our query there. So I'm going to insert into students and so on. All right, so let's make sure that we have our count here instead. Place my count down below. And then I'll select all from students as well. All right, so I'm going to select the count. We're going to see 5. From there, I'm going to insert a new student. Then I'm going to select the count again, which should be 6. And then I'll select all from students. All I'm doing here is I'm inserting a new instance or a new instance of this class, a new row into the table with the correct values added into them. And this is the command to do so. Insert into name of the table, the values that it's expecting to receive. Specify that the next rows or multiple rows are going to be the values that will be entered. And then pass them in. All right, so now let's execute our script now. We drop the table, create the table, we copy 5. Here's the list of relationships. The count is 5. We inserted 1. Now we have a count of 6. And you can see there at the end that Francisco Avila has been added. Okay, great. Now, why is this important? Why are we spending the time to take a look at this? Well, if I change this ID into 1 and I execute this code, we're going to get an error because it's going to tell me, hey, the key of 1 already exists. Well, that makes sense. But that means that every time I have to add a new ID or every time I have to create a new instance, I'm going to have to do it where I include the ID. And I'm going to have to keep track myself of IDs that are being utilized. I'll have to write logic here to make sure that IDs aren't being reused over and over again. So instead of doing that, what I'm going to do is I'm going to change my script a little bit. Instead of having integer ID, I want this to be a serial primary key. Everything as far as copying students is going to remain the same. And I'm going to insert my student data. Utilizing the insert command. So instead of copying from a CSV file, I'm going to insert each one of these values. Now notice that when I go ahead and run the insert into students, I'm now only passing first name, last name, age, and grade. I'm not passing an ID anymore. So I'm going to go ahead and not pass an ID here as well. All right, now let's see what our script behaves like. Now when I run the script, it drops the table, creates the table. We still have a count of 5. because those are the 5 that I inserted. We then get an insert of 1, and everything looks right. But if we take a look at the ID here, notice the ID has been automatically generated to be from 1 all the way up to 6. So how is SQL handling that? If I take a look at my relations, if I take a look at my relations here, not only do I have a table for students, but now I have this public students ID sequence. So this public students ID sequence, where did that come from? Or when was that generated? That was generated here. When I created the table and I said, hey, this ID will be a serial primary key, PostgreSQL said, oh, you want me to take care of the fact that this is serialized and you want me to take care of the ID and managing ID generation for new instances. No problem. Now that you've told me that, this is how I'm going to handle it. It creates a completely separate sequence or almost a table that you can still run queries against. So I'm going to select all from students ID sequence. And here we're going to see that the last value that was called was 6. The log count is 27, which actually I'm not exactly sure why that's giving us 27. And then it gives us an is called variable. All right, I'm actually going to copy this query here. I'm going to run this query prior to our insert statement. And I'll run it again post our insert statement there. All right. So here we go. We run our we run our schema. We drop the table, create the table. After the table is created, we take a look at the sequence. We can see that the last value within the sequence is 1. And notice that is called is set to false. That's because I haven't generated anything inside this table. So since I haven't generated anything inside of this table, the first instance, which in this case is John Doe, will receive the ID of 1. When John Doe is now created, or all 5 of these instances are created, I now get the last value that was utilized was 5, and I get this is called is true, meaning that the next instance that gets created, rather than utilizing 5, would increment and utilize 6. And that's how SQL manages ID generation. And that's the key difference between serial primary key and integer primary key. All right, does anyone have any questions over the difference between serial and integer primary keys?
So the primary key is always going to be a number, presumably. Is that correct?
No, not correct.
Okay.
Here within the program, yes, it's always going to be a number. In the professional world, you might deal with something called UUIDs. And if you want to take a look at that later on, I strongly recommend that you do so. It would be really impressive if you integrate that to your personal projects later on. But that's going to be more of what you see. It's going to be a combination of both integers and characters set as IDs.
And can you use serialization for that as well? Or do you have to write some kind of logic to determine it?
No, you can still utilize serialization. Yes, that will be managed in combination between PostgreSQL and Django.
Thank you.
Of course. Any other questions?
So the serial key can't be repeated. What about any other values in the table?
The serial cannot be repeated, but you're saying what about other values on the table? What do you mean?
Yeah, like so you had a value that's like not one of those values, just you get a value like email. Could somebody put in the same email as somebody else?
Yes. In order to specify constraints, which we'll be going over later, you would have to add something like the keyword unique. And then by adding that unique, it would essentially say, hey, no other instances of this can exist. So if you were managing users, their email would be something that you would want to be unique. All right. Any other questions?
How would you drop an entry instead of creating one?
All right. So dropping an entry, let's go ahead and do that one. Ooh, putting my SQL knowledge to the test this time. Not going to lie. Let's see. I believe it's drop data from students where first name I believe that's the correct syntax. Let me go ahead and execute that. Nope, that's not it. There you go. It's not drop, it's delete. There you go. All right. And let me copy this to make sure it comes over. So in order to remove an entry, you would run delete from students where, and then make sure that there's a where clause to specify which instance is it that you want to remove. And that's how I would drop or delete the one entry. Does that answer your question?
It does. Because you can't repeat an ID, will it reuse an ID if you added another student after that? Would they just be six?
Yeah, let's try it out. Let's see. And let's run another select query here. All right. Our script is starting to get a little hefty. All right, so we create a table, we drop the table. We can see that it hasn't been called in the serialized key. 5 of them get inserted. Now we do have a call for that serialized key. It is at 6. All right, Francisco being the last one. That gets added. All right, so now we should be at 7. We delete 1. There's my select query for all of them. It still gives me the value of 6. But now notice that when I created a new instance, instead of reusing the value of 6, it now promotes me to 7. All right, so it's not going to reuse an ID. And that's one of the best things to use when it comes to serial primary key.
So is it typical practice to, in the very beginning of this file, you had drop table if exists students? If you were using that ID for, say, like a student ID number, you would not want to do that, right? You would just want to remove records and append them at the end. Because otherwise you're reassigning an ID depending on the students.
Got it. I see what you're asking. If I was working with CSV data that was being handed in, so I got the situation that you're describing is I get CSV data from someone, or they're providing me a data table saying, hey, this is the information that I want you to run queries against. I would still do this drop table if exist, mainly because my very first couple of commands would be creating the table and then copying the table. Note that I wouldn't be working within the actual real database. All of my work would be within a mock database that I have living inside of my machine, or that we have living inside of some sort of cloud server. There, I would run all of my mock, or all of my queries, all of my experimentations until I'm able to generate the report that I want. And then I would remove this drop students and the create table before I push it up. That way, somebody else can quality assure it, make sure it works. They make a copy of the real data, run it against that real data inside of that copy. It generates a successful report. Then they push it to the live client data in order to successfully make reports. Does that answer your question, Tim?
It does. Thank you.
Of course. All right. Awesome. Well, if there aren't any other questions, oh, yes, I do want to terminate that actually. If there aren't any other questions, I apologize. Today we covered what and why RDBMSs, relational database management systems. We went over building a database with current skills to identify problems. I saw DB and I almost said dumbbell, but in this case we're in database. And then part two, we also covered why we were diving into PostgreSQL. We covered some of PostgreSQL basic commands, working with CSV files within Postgres, executing schemas, and a very few amount of SQL queries. At this point, does anyone have any questions over anything that was covered in today's lecture? Doesn't seem like we have any questions. I'm going to go ahead and stop our recording here.